Hi again. So this is part 2 of my UV mapping series, and in this one we're going to look at this component. It's actually a part of a robotic arm, but it doesn't look like much right now, and we're going to UV map it. So what I like to do is I like to start with a test pattern. So one thing that's worth noting is that this arm, this robotic arm component, has just a Phong tag. I've deleted the UV tag. There's no texture applied. So what I can do is I can drag this test pattern that I have right here. It's just a grid of colored numbers, 1 through 0, and well, 0 through 9, or however you'd like to say that. And it is just used so that I can see which way is up, which way is down, and if there's any distortion. So if I apply this texture, by default in Cinema 4D, if an object does not have a UV tag, it gets spherical mapping. So it's spherical mapping from the origin of the object, which is over here, and we can see the stretching and the problems that happen. So your first reaction might be to try a few different mapping methods, and sometimes you can get some really good success with that. If I do cylindrical mapping, we can go to the texture mode. You can see the actual texture part here. You know, I'm gonna scale this up. I'm gonna scale this object up a little bit, just so it's a little easier to work with. It's really not that large in reality, but I'll just scale it up a little bit. So what I can do now is I can actually scale the cylindrical map down, and we can see how as I scale it up and down, the projection changes. And we can try to get some mapping angles that work a little bit better. Like, see here, we can start to see the numbers. And I'm sure if we were to scale this larger, the numbers would start to look a little more or less distorted. But it's just really not what we're looking for. If this was a meaningful texture and we had to apply it, this sort of stretching and pinching just wouldn't do. Now, a common technique that I often used was to use cubic mapping. It's really good for repeating patterns because you usually don't see the seams, but you can still see them if you look for them. So at a glance, this looks like a really good job of mapping. The numbers are all lining up. They're facing the right direction. It looks good. Even up here on the top, it looks like the mapping job is really well done. Now, this works fine for most circumstances, but you do get some instances where this just won't work. Let's say you needed to paint a bit of detail that went all the way around this arm. Well, that would be really difficult to do because right here is a seam. It's hard to see, but if we were to move this texture projection around a little bit, you start to see the seam. You see where the 9, 8, 7, 6, 5 start to cut off, and that'll show up just as a seam in your in your texture. If I take these stones and apply it as a texture, you can see the seam really clearly. Now, UV mapping is not a cure for seams. You're still going to have seams in certain spots, but for areas like this where it's just not sure which part of the cubic projection it's using, I mean, we have these blocky looking areas right here, and then we have a transition right here where it goes from light to beige. These are all things we can avoid by UV mapping. So let's get into some techniques for UV mapping and we'll see how that goes. I'm going to reapply my ugly test pattern and let's get started. So when I look at this object, I identify a few characteristics. One of the things that I see is that if I were to do a loop selection all around the sides, that's almost like a continuous strip of geometry around the object. I'm pretty likely to want to paint details on the edge of this object, so we should probably map this as a continuous piece. We can also select the parts of the strip right there, so it's actually 3 polygons wide instead of 1 polygon wide. So let's start by mapping this. I'm going to switch to the body paint UV edit mode. And what that gives us is a view of the current mapping mode if show UV mesh is turned on, even if it doesn't have UV coordinates. Notice our object doesn't have them yet. This is important because when we play with different mapping modes on our tag, for instance, if we did cylindrical, you see here that this representation changes. Now cylindrical is what I want for this instance because I like the way that the numbers wrap around seamlessly. However, there's always a seam. That's one of the things about UV mapping. Because you're basically taking a three-dimensional solid, tearing it somewhere and then laying it out flat, there's always going to be that edge where the two bits meet. So if I go back to my texture projection tool right here, we can see here that it is indeed cylindrically mapped in the orientation that we'd expect, and I think that's good. One thing I do want to watch out for is the seam. So here on the texture widget, there's this red loop here that defines the U edge, and then there's this green bit here that defines the V edge, I believe. So this green bit is basically where the cylinder wraps around and meets itself, or the seam. So what we can do is, before assigning the UV coordinates, which is going to be our next step, we can actually rotate the cylinder around and we decide where the seam is. If you look carefully, the seam is actually between 9 and 0, where our texture repeats. So let's say that we knew where this part was going, and it was okay if there was a seam on this side of the object over here. So we just position our green line sort of where we're okay with that seam appearing, and we see the preview update over here. And then we can go to polygon mode, make sure we have the correct polygons selected. And once we know we have the correct polygon selected and we know that our projection is good, we can actually go to the tags menu and just say assign UVW coordinates. The W is an extra letter in the coordinate system where there's a little bit of debate. I didn't really find a convincing reason why it's there, but people use it, mostly in software. But in general, we just call it UV. We leave out the W. So now that it's mapped, the only thing that should have changed really in terms of you looking at this is that it's now UV mapping. So assigning the UV coordinates adds a tag, and it also changes the mapping mode to UVW mapping. You can see that some of the areas of the object look a bit questionable at this point, but we're going to fix that. So if we go up here to this tool, it's the UV polygons tool. We see over here on our UV map that the polygons we just assigned are selected. Now what I like to do is separate an object into discrete shells of UVs. So I'm going to use the move tool and select and move this away. So one of the things that we can notice about this is that the seam is right where we put it, right here. So this is one end of our UV shell and this is the other end. So these two polygons border the seam. Now what's left over is this stuff. Now all of this other stuff here is basically what the rest of the object looks like if it were to be cylindrically mapped with the same method we just used up here. It doesn't look great, but we'll get to that in a bit. So now that we have this area mapped, we can actually relax it and unfold it. And it'll get rid of the distortion we're seeing here by the number 7. So there's a few tools for that. I'm going to use my rectangular selection tool to select certain regions of it while I work with it. And I'm going to use this panel down here, the UV mapping panel, under Relax UV. So there's a couple options: pin border points, pin to neighbors, pinpoint selection, cut selected edges. By default, let's keep everything off. And let's see what happens when we just select the polygons we're interested in and then say apply. So it sort of distorts things a little bit in this view. It twisted our object a little bit as well. But if we look here in the perspective view, it looks pretty perfect. If we were to rotate this so it's not twisted anymore, we can actually see it looks really good. We have 2, 3, 4, 5 wrapping right around to 6, 7, 8, 9 pretty seamlessly until we get to the seam over here and it restarts from 0. So we can move it around and you see it projects on different parts of the map. But let's undo and see how else we can do that. We can actually do that one bit at a time, I believe. If I took my rectangular selection tool and I only selected the polygons on the right half and ran that same command, something weird happens. It just tore it off. Well, if we had the pin to neighbors option selected, these polygons here are going to stay pinned to their neighbors, usually referring to the deselected neighbors. So if I run this command again, we can see here that the distortion is a little bit less. It still skews a little bit over here, but it's sort of stuck to the same dimension and it didn't twist away as much. We can then sort of invert the selection a little bit, run the command again, and it does the same thing for the other side. We can continue to sort of select little parts of the strip of polygons and relax them, and after a while it seems relaxed enough, and what we have is we basically have this area of the object with that seam that you're seeing, and that's the only seam we're dealing with. Now the cool thing about knowing where the seam is, which is something that you typically have a harder time with cubic mapping, is that if you know where the seam is, it means that you can actually paint around it, or you can avoid it. And that's a really powerful thing to be in charge of. So now that we have the outside of this object mapped, it makes perfect sense, I think, to map the underside of it. So what we can do is actually use this UV view as a selection helper. It's another one of my favorite things to do. So if we're in UV polygons mode, we can actually just select these polygons, which represent the base of the object, the underside rather. So now that the underside is selected, what we need to do is assign new UV coordinates to it. The best way to do this is to select your texture tag, change it from UV mapping to something else appropriate, so like flat, and then reposition it. So I'm going to grab my texture tool here, select the object, and I'm going to rotate it so that it's parallel with the base of the object, the underside, like that. So it's 4, 5, 6 flowing in the right direction, and we can see here in the UV view that my projection has changed. If I were to rotate this at an arbitrary angle, you see it changes as well. So we're sort of seeing through the eyes of the projection in the UV view. So with it nice and flat, what I can do is ensure that I still have those polygons selected, and I can say assign UV coordinates again. So doing assign UV coordinates is not going to erase our UV coordinates from earlier because we don't have those polygons selected. So if I say assign UV coordinates, it assigns the UVs we just had selected in addition to the ones that we did earlier, which you can see are still intact up here at the top of the texture view. So we can then return to our UV polygons tool, and we can sort of rotate this into place in a more convenient fashion. You can see it moving over in the 3D view as I do so. And what we can do is sort of move it into place, and then we can just relax it. So when I press relax, you'll see a really slight change, but the big change happens near the corners right here. Since these were flat mapped, but there's kind of at an angle, there's a little bit of distortion at the edges, and so by applying the relax UV, you can see the edges sort of spread out. But in general, when you relax the entirety of a UV shell like this, stuff gets distorted that really shouldn't get distorted. Let me see if I can explain this. These polygons right here, the ones, let me get a selection tool to select just the polygons I'm talking about. These polygons are perfectly mapped. They are flat, 100% flat as you can see, and we map them flat. So when we relax these UVs, these polygons in the center should not move, but they do, because it's kind of like laying a sheet or a tarp on the ground and then tugging on the corners. The middle is going to move a little bit. So when we apply the relax to this, keep an eye on this center spine here, and you'll see that it moves a little bit. These polygons get a little bit bigger, things sort of shuffle around. In the 3D view, it may not be immediately apparent that stuff is a little distorted, but if you drew pinstripes or other straight geometry on this bottom surface, you'll see the distortion. The cool thing is you can actually fix this issue by just deselecting those polygons that are in the middle. So using my selection tool, holding down Control, I can deselect the polygons that I am certain these polygons are mapped properly. They don't need to be relaxed. Then, because the pin to neighbors selection is checked, only the polygons around the edge are going to be relaxed and unfolded. So if I use that command, you can see all that happens is the polygons around the edge just get a little bit wider. And that's really all that needs to happen there. And that part is done. So we're beginning to see that we can get really fine control over how the different surfaces of the object are mapped if we use UV mapping. Next up is the top. So I'm going to repeat the process. I'm going to go to flat mapping. We already see that it's sort of mapped, but things are backwards. This is where the test pattern comes in handy. So I can then rotate my test pattern 180 degrees so the numbers are now legible again. I'm going to use a similar technique where I am just going to, I lost my tool, where I'm just going to select the polygons that I'm interested in. So it's these polygons and everything inside of them. So I'm going to use the fill selection tool. These polygons on the top are the ones I'm interested in. So I have those polygons selected. I have my flat projection set. And the next step is just to assign the UV coordinates. And again, we see our existing mapped items along with our new item that we need to move into position. So we're going to move this one into position, and we can apply a similar technique, sort of similar to what we did with the previous sort of teardrop shape, in that we can say, okay, I know for sure that these polygons here around the edge don't really need to be relaxed or flattened at all. So we can deselect all of those, and then we can run our relax command, but something interesting is going to happen. Maybe not that interesting. The ones around the edge behave as we expect, but the ones in the middle have this strange sort of issue where the distortion almost seems pronounced. And that's because of this situation here. You can see here the number 3 is being distorted severely as it goes up this sort of cliff face. Now when we relax, it fixes that problem, but now the number 3 is very distorted. The bottom part of it is sort of larger than it should be. You can see the number 4 is kind of distorted as well. And that's because we have said do not move the polygons that are deselected, but go ahead and shuffle around and relax all the polygons that are selected. And that includes these polygons here in the middle. Now, if we wanted to do seamless painting from this surface all the way down into this hole, we're just going to have to deal with that distortion. But if we're okay with creating another seam around the edge of this, we can just move those central polygons away onto another part of the shell. Now the easiest way to do that is actually just to select the polygons you are interested in. So I'm going to select all these polygons here on the outside part, and I'm just going to move them away. When you do that, it actually tears the UVs away and it leaves the other UVs behind. The UV polygons, that is. So now I can scale this down and scale this up, and you can see the seam that I've created right here. But that's okay because we're in control of where that seam appears, and as we get better at UV mapping, we can sort of determine where it's okay to have a seam, where we can hide it with other geometry or clever texturing. So now that we have this this outer part of the top shell selected, we can apply the same technique we used earlier. We're just going to deselect the inner part of the polygons, the ones that we know are mapped correctly, and then apply our mapping. It relaxes the outer edge. It looks good. And now we're going to do the same thing here. So I'm going to use a rectangular selection, And then I'm going to use my live selection tool and deselect these ones in the center, because again, I know that they're perfectly flat. And I know that it's okay to not relax them. I think I missed two up here. So we have those ones in the center deselected, and we can now hit the apply button, and again, it sort of relaxes it. You will notice some strange stuff happening here. And I'm not entirely sure why that is. Maybe I accidentally deselected something I shouldn't have. Let's try that again. Yeah, so if I apply it regularly, the center part gets stretched. Let's see what happens if I just deselect a few polygons. There we go. That's what I was expecting. I'm not sure what happened there. I must have accidentally deselected a polygon that I didn't mean to. Maybe one of the vertical polygons along the edge. And so now if I hit apply again, it stretches out the sides, but it leaves the flat part of the center intact. Here you can see the distortion on the number 3 and the number 4 are much less severe. So this is good. We actually have all the shells of this object relaxed now, but they're different sizes. And there's also a tool that helps us fix that. So we see here that the strip around the edge is huge. We have 6, 7, 8, 9 very large. The one on the top is a smaller grid, and they're all different sized grids. Luckily, there's a sort of a realign tool that'll help us with that. So if we go to the optimal mapping tab, there's a realign option. So we can realign these shells with a few options that are right here. There's a spacing option, preserve orientation, and equalize island size. So equalize island size will make all of these islands or shells the same size relative to each other. So it means that these 3 teardrop shaped parts are going to change scale drastically. I'm not sure what's going to happen to this strip. Now if you say preserve orientation, it will not rotate them. If you uncheck that, it might try to rotate them for a good fit. I'm going to uncheck that, see what happens. So when I press apply, it shuffles them all into the space, and it sort of makes them the size they should be. Now one of the things that you're going to notice right away is that it seems like we're wasting an awful lot of space. Well, that's because this strip of polygons here is quite continuous. This strip of polygons, we can't fold it or bend it or anything because this is our map. That's just how we mapped it. However, if we're willing to add another seam, again, if we're strategic about where we put our seams and we know the context of the object, it might be okay to add another one. But if we added another seam, we could maybe pack these objects in here better. The other option that you might want to consider is the idea that this strip might just need to be long and the others can be scaled up. Now that does destroy the relative scale of your UV map, but if you didn't need much detail around the edge, but you wanted more detail on the top and the bottom, this might be a good option for you. In this case, I'm going to add another seam. So if I select all of these polygons right here, we can see that we'll have one seam here, and then it'll wrap around the front. We have another seam right there. In this imaginary world where I'm actually doing something practical with this object, I'm okay with that. So I'm just going to select these polygons and move them over just like that. So now, relative to each other, the objects are all sort of more similarly sized and they can be packed into the UV area better. So if we hit apply again, we can see it's a much better fit. And we can hit apply a few times, it runs its iterations, and we have some stuff that looks pretty good. The spacing parameter is so that you can paint different parts of it and the painting doesn't bleed from one object to another. For instance, if that was set to 0, the objects pretty much bump up against each other, and if you wanted the strip on the outside to be red but this inner part to be green, you might find the colors bleeding into each other because they're so close together. So what you can do is increase this spacing to whatever you need, and it applies a relative border around each object. It sort of helps you out. Now that we have this mapped, we can actually switch back to our standard mode. And we see here that we have this object with really deliberate mapping. The seams are only where we say they are. So this is a smooth transition. The only seam is this one right around the edge, which we know about. So maybe we can conceal that seam with a pinstripe or some damaged metal. There's all sorts of ways that you can conceal the seams. And we can just apply this stone texture and it should map pretty well. All of the areas where we applied the stone texture, it's the same size. It's again, the seams are only where we said there would be seams. And you know, this is sort of a semi-practical application of how you would use UV mapping. You can even tile the UV map. So I can say I want it to be 4 tiles by 4 tiles. And we get this stone pattern wrapping smoothly around the edges where it's UV mapped. And this might come in handy in our next video in this series, where we're actually going to look at a practical use of UV mapping. This example was more of an exercise, but in the next video I hope to show you guys how to take some text, UV map the text, and apply interesting textures to it. One of my viewers was asking me specifically about getting an effect that kind of makes it look like cheese, or like a sort of a rocky undulating surface on the text, and that can be difficult to achieve if you don't UV map it. So we're gonna be hopefully looking at that in the next video. But until then, I hope you guys enjoyed this and I hope you learned something, and see ya.